Building an AI application feels easy at first. You just send a string to an API and get a response. But as your app grows, you realize you're drowning in spaghetti code, managing system messages, user variables, and output formatting across 50 different files. If you change one adjective in your prompt, the whole system breaks. This is why we need LangChain, not just as a library, but as a framework for natural language programming. Today, we're mastering prompt templates and the LangChain expression language, or LCEL, to build AI systems that are modular, testable, and actually ready for production. Think of a prompt template as the function definition for your LLM. In traditional coding, you don't hard-code values, you use parameters. A prompt template allows you to define the structure of your instructions while leaving placeholders for dynamic data. But it's more than just an F-string. It handles the logic of roles, system, AI, and user, which is crucial for chat models. For instance, a chat prompt template ensures that your system instructions are always prioritized by the model's attention mechanism, something a simple string concat can't guarantee. Let's get our hands dirty. We're importing ChatPromptTemplate. Notice how we use a list of tuples. This is the gold standard for maintaining context. But what if part of your prompt is static? Say, the company name. We use partial variables. This allows you to pre-fill parts of a template and reuse it across different functions. It's essentially currying for your prompts. This modularity means you can swap out the persona of your bot without touching the core logic of the user interaction. In the early days of LangChain, we used LLMChain. It worked, but it was a black box. You couldn't easily see what was happening inside. Now we have LCEL, LangChain Expression Language. It uses the Unix pipe operator. If you've ever used Bash or Elixir, this will feel like home. The data flows from the prompt into the model and into an output parser. This isn't just about pretty syntax. Because LCL uses a standard runnable interface, every chain you build automatically gets support for streaming, async operations, and even batching out of the box. You write it once, and it works for every production scenario. Here is the expert-only insight. Every component in this pipe is a runnable. This means they all share a common protocol: invoke, stream, and batch. If your chain takes 5 seconds to generate a full response, you can simply call chain.stream, and your frontend can start showing words immediately. No extra code required. This is the difference between a junior dev waiting for an API and a senior dev building a responsive UX. Furthermore, LCL handles retries and fallbacks natively. If your primary model fails, you can pipe it into a backup model with one line of code. Real-world AI doesn't just go in a straight line. Sometimes you need to fetch context from a database while simultaneously generating a search query. This is where RunnableParallel comes in. It allows you to split the data flow, process branches in parallel, and then merge them back into a single dictionary for the next step in the chain. Imagine you're building a tool that summarizes a document and translates it at the same time. With LCL, this is trivial. You're no longer just calling an LLM, you're orchestrating a symphony of data processors. So how do you apply this today? Start by identifying your hard-coded points. Every time you see an F-string or a manual API call, replace it with a prompt template and a chain. Use LangSmith to trace these chains. Because LCEL is structured, LangSmith can show you exactly what the prompt looked like right before it hit the model and exactly what the parser received. This visibility is the final piece of the AI engineering puzzle. You're building a system that is observable, debuggable, and scalable. You aren't just prompting, you're engineering. If this deep dive helped you move past prompt spaghetti, hit that subscribe button. We're building a full series on AI engineering. Next up, we're tackling vector databases and retrieval-augmented generation, or RAG, using the same LCL patterns we learned today. Download the code for this episode in the description. Now go build something smarter than a chatbot. I'll see you in the next one.